Hey, Deep Divers, ready to dive into the world of AI.
Always ready.
Today, we're going to be looking at how AI handles those tricky recursive patterns.
Those Russian nesting doll patterns. I love those.
Exactly, exactly. And to help us unpack all this, we've got an awesome research paper.
Oh, yeah, the initial findings paper by Carrie Draper. I've been looking forward to this one.
Me too. Plus, we have 3 whole AI-generated data sets to play with.
That's right. And what I find really fascinating about this research is how Draper really focuses on the way AI interacts with the data. It's not just reading it, it seems to actually be grasping those recursive relationships.
You're saying it's like the AI is starting to understand the data almost like a human would.
Yeah, kinda. Like it's figuring out the structure beneath the surface.
So tell me, what makes these data sets so special? Like, why these specific ones?
Well, Draper created 3 very distinct datasets, each with its own unique flavor of recursion. One mimics fractal patterns, like, those crazy self-repeating images.
Right, right.
Then there's one that's all about time series forecasting, predicting future values based on past trends.
Okay, got it. So what's the third one?
The third one's super interesting. It focuses on hierarchical decisions, like a chain of choices building upon each other.
Ah, I see, I see. So each data set has this kind of building upon itself element baked in.
Exactly. Now, to really put these data sets to the test, Draper used an AI research tool called NotebookLM. Think of it like a superpowered AI platform that can analyze and synthesize tons of information.
So they just fed these data sets to NotebookLM and said, figure it out.
Pretty much. No hints, no clues. NotebookLM had to figure out the type of recursion present all on its own.
And, drumroll please, did it manage to crack the code?
Oh, it did. And here's the kicker. It didn't just spit out a jumble of numbers. It actually pinpointed the specific type of recursion present in each dataset.
Whoa, hold on. So it's not just recognizing a pattern, it's actually categorizing it without any hints.
Exactly. It's like it's understanding the core concept behind each data structure.
Okay, now that is mind-blowing. Give me an example. How did it do that with, say, the fractal data set?
Well, with fractals, you have that self-similarity thing going on, like how each little piece of a fractal is like a mini version of the whole thing.
Yeah, like those Romanesco broccoli.
Yes, precisely. So NotebookLM, it spotted that self-similarity in the data and how the complexity grew with each iteration, just like a real fractal.
But how do we know it's not just recognizing a pattern, but actually getting the concept?
Yeah.
Like, how do we know it's not just mimicking human-like thinking?
That's the million-dollar question. And honestly, that's what makes Draper's work so groundbreaking. One way to think about it is that NotebookLM seems to be organizing this information into frameworks, much like how our minds connect different concepts.
Okay, so it's like it's going beyond just pattern recognition and starting to form an actual understanding.
That's the idea. And it did this with all 3 data sets, not just fractals.
Oh, tell me about the others. What about the time series one, the one that predicts stuff?
Right. So with that one, NotebookLM figured out that the key was in understanding how errors are corrected based on previous information. Like it understood the idea of learning from mistakes to make better predictions.
So it's like those predictive text things on our phones, but way, way smarter.
A much more advanced version, yeah. It's taking that concept of prediction and applying it to a whole complex data set, demonstrating an understanding of how past data influences future outcomes.
Okay, and the third one, the one with hierarchical decisions. What did NotebookLM make of that?
This one was all about how errors in past decisions can impact future choices and their costs. NotebookLM grasped that minimizing those costs as the complexity grows was essential. Imagine building a tower of blocks. Each time it falls, you learn a bit more about balance and stability to improve your next attempt.
I see, I see. So it's like the AI is understanding how the consequences of past choices can influence future decisions.
Precisely. And this ability to connect the dots between past errors and future outcomes, that's what makes this research so fascinating.
I have to ask, though, is NotebookLM just like a super advanced calculator, or is there really something more happening here? How can we be sure it's not just mimicking human-like thinking without truly understanding?
It's a big question, right? It's what keeps researchers up at night. To really grasp how this could be more than just mimicking, we need to delve into something called Recursive Prediction Error Minimization. Recursive PM for short.
Recursive PE. Okay, that sounds a little intimidating. Break it down for me.
Well, imagine you're learning to ride a bike. Each time you wobble or fall, that's an error. But each error teaches you something, so you adjust your balance the next time. That's the basic idea behind prediction error minimization.
Got it. So it's all about learning from mistakes.
Exactly. But recursive PEM takes it further. It uses the errors from past predictions to make future predictions more accurate. It's like you're not just learning to stay upright on the bike, you're learning to navigate obstacles, even do tricks, all based on those early wobbles.
Wow, so each mistake the AI makes actually makes it better at predicting the future.
That's the idea.
Okay, so that's PEM, but where does the recursive part come into all of this?
Think back to the bike. You're always adjusting based on past errors, right? And each adjustment changes the next one. It's a continuous feedback loop where past experiences directly impact future actions.
So the AI is constantly refining its understanding based on the errors it makes.
You got it. It's like a constant learning cycle, leading to more and more accurate predictions over time.
So how does all this recursive PE stuff connect back to those data sets we were talking about?
That's where things get even more exciting. We need to look at each data set through the lens of recursive PE. That'll help us see how this concept might be driving the AI's ability to actually understand recursive data.
Okay, my mind is already blown.
Yeah.
But let's not get ahead of ourselves. Let's take a closer look at each data set and see how recursive PEM plays out in practice. Ready to dive deeper?
Absolutely. Let's unravel this world of recursive AI together. We'll revisit that time series data set first and see what treasures we can uncover. So this time series data set, remember, it had things like value, error correction, and prediction confidence all changing over time.
Right, like trying to predict the stock market, trying to figure out where the price is going to go next.
Exactly. And what we see in this data set is that how much the prediction needs to be corrected, the error correction part,
Yeah.
it seems to be really tied to the previous values.
So it's not just seeing, oh, I was wrong. It's like the AI is figuring out the pattern of those errors over time.
You got it. That's what makes recursive PM so cool here. If we look at these errors through that lens, it could lead to way more accurate predictions.
Wow, okay. So if this could help us understand something as complex as the stock market, imagine what else we could do with this, right? Like what other systems could we model?
So many possibilities. But you're right, let's stick with our data sets for now. We've got that fractal one next, remember, fractal dimension and recursion depth.
Yeah, and the AI just figured out how those two were connected, all on its own. As the fractal got more complex, that recursion went deeper.
Exactly. It wasn't told that connection, it discovered it. And this is where recursive PEM really comes in. See, these recursive PM algorithms, they can help model how those two factors, the dimension and depth, they affect the overall complexity of the fractal.
So the AI is using this recursive PM to understand how the fractal gets more and more intricate as you go deeper.
Exactly. Each layer adds more detail, more complexity. Recursive PM helps the AI model that and adjust its understanding.
Okay, that makes sense. But how does that translate to the AI actually learning something new?
Well, as that recursion goes deeper, things can get tricky, even for AI. It risks becoming unstable, focusing too much on the specific data it was trained on.
Like getting lost in the details and missing the bigger picture.
Yep, that's where adaptive learning rates come in. Basically, the AI adjusts how fast it learns depending on how complex the data is.
So it's like it's learning to pace itself,
Yeah,
taking smaller steps as things get more complicated.
exactly. It's a clever strategy that helps the AI navigate those complex recursive structures. But we've got one more data set to explore. That decision-making one. Ready for that?
Oh yeah, definitely. That one got me thinking about like how AI could revolutionize things like finance, where every choice has consequences that ripple outward. Remind me, how did that data set work again?
This data set was all about how errors in the past, those can affect future decisions and the costs that come with them. Think of it like managing a budget. Every time you spend money, it changes what you can do later.
Like if you splurge early on, you might be in trouble later.
Exactly. So here we see recursive PM helping the AI analyze how much past errors were impacting things. Like, it recognized that past mistakes can either make future decisions harder or easier.
So it's not just learning from mistakes, it's understanding how those mistakes change the whole game going forward.
Exactly. It's developing a kind of risk awareness. By looking at those past errors, the complexity and the costs, the AI learned how to make decisions that kept costs down and helped it avoid those pitfalls.
That's incredible. Imagine if we could apply this to real-life decisions like, I don't know, government policies, or even just personal finances. Like an AI advisor that could help you make smart choices based on your past spending habits.
There you go. The potential applications are vast. But before we jump too far ahead, there's something we need to address. Remember earlier you asked about how we know all this isn't just the AI mimicking human thought?
Yeah, that's been bugging me this whole time. How do we know it's actually getting it and not just putting on a really good show?
That's the heart of the matter, isn't it? It's a question researchers are wrestling with constantly. There's no easy answer. But one thing that points to something deeper is how these AIs can apply what they've learned to brand new situations.
So it's like they're taking the principles they've learned and using them in ways they weren't specifically taught. That does suggest a level of understanding that goes beyond just mimicking.
Exactly. Like learning the rules of grammar and then being able to write a poem or compose a song. It's about creating something new, not just repeating what you've heard.
Okay, I get that. But why haven't we heard more about this research? If it's so groundbreaking, shouldn't everyone be talking about it?
Well, for one thing, this research is still fairly new. The AI field moves so fast, it takes a bit for these discoveries to really reach the public.
So it's like the scientists are still trying to figure out what it all means.
Yeah, exactly. Plus, anytime there's a new discovery, there's bound to be some healthy skepticism. Researchers want to be careful before they make any big claims.
That makes sense. Double check everything before you shout it from the rooftops.
Precisely. And that's actually where Draper's research takes a really interesting turn. They issue a challenge not just to the scientific community, but to anyone interested in AI.
Oh, what kind of challenge?
Draper wants everyone to download these data sets, experiment with different AI tools, and see what happens. They want people to test these findings themselves.
That's pretty bold. It's like saying, put up or shut up.
Exactly. And what's great about this challenge is that it opens up the research to a wider audience. You don't need a fancy lab or a PhD.
Love that. Everyone can participate in the scientific process. So for our listeners out there who want to take on this challenge, what kind of questions should they be asking as they experiment?
Great question. Draper gives a few pointers. The big one is, does the AI you're using find the same recursive structures, those feedback loops, those hierarchical trade-offs that NotebookLM did?
So it's like a test to see if different AIs come to the same conclusions or if they see things differently.
Right. And if there are differences, why is that? What could be affecting the AI's ability to recognize and understand the recursion? Is it the type of AI, the data it was trained on, or something else altogether?
Those are some really deep questions. It's like we're not just exploring the capabilities of AI, but the very nature of intelligence itself.
You got it. And that's what makes this whole thing so captivating. It's not just about the technical stuff, but the bigger philosophical implications too.
This whole deep dive has been an absolute whirlwind. We've gone from exploring the nuts and bolts of this recursive AI to pondering what intelligence really means.
It's been a fantastic journey. Hopefully our listeners are feeling just as curious and excited about the future of AI as we are.
Speaking of our listeners, let's bring it back to them. Why should they care about all of this? What's the takeaway message?
The reason they should care is simple. Recursive AI and this PEM thing we've been talking about, they have the power to completely change how we do so many things. It's a whole new way of thinking about how we solve problems, make decisions, even understand what intelligence really is.
Okay, I see the potential. But give me some examples. How could this impact everyday life?
Imagine healthcare, where your doctor can use AI to create a treatment plan specifically for you, based on your genes, your lifestyle, your medical history.
Wow, that sounds pretty futuristic.
It is, but it's the kind of future recursive AI could help us build. And it's not just healthcare. Think about something like financial markets. They're incredibly complex, right? But with recursive AI, we could potentially develop much more accurate forecasts. That would mean better investments, a more stable economy.
What about climate change? Could this help us tackle that?
Absolutely. We could use recursive AI to analyze tons of climate data, identify patterns, predict extreme weather events better. It could help us make smarter decisions about energy, develop sustainable technologies. The possibilities are huge.
It seems like there's no limit to what we could do with this.
And that's why it's so important for everyone to understand this technology. The future is being shaped by AI, and we need to be a part of that conversation.
That's a great point. It's not about just watching AI happen. It's about engaging with it.
Exactly. The more we explore, the more we realize how much there's still to learn. It's both inspiring and humbling, honestly.
You know, as we wrap up, one question keeps popping into my head. We've talked about all the good things recursive AI can do, but is there a flip side? Are there any potential risks or downsides we should be thinking about?
That's a really important question to consider. It's like any powerful tool, right? Recursive AI has the potential for both good and bad. It really comes down to how we decide to use it.
So what are some of the potential risks we should be keeping an eye on as this technology keeps developing?
Well, one concern that a lot of people bring up is the potential for misuse. Like, as this recursive AI gets more and more sophisticated, it could be used to do some pretty shady stuff, creating those super convincing deepfakes, for example, or even manipulating things like financial markets in a way that could really hurt people.
Yeah, that's a scary thought. It really underscores the importance of having ethical guidelines and regulations in place.
Mm,
We need to make sure that this technology is being developed and used responsibly, that it benefits everyone, not just a select few.
absolutely. It's like the classic saying, right? With great power comes great responsibility. And that responsibility doesn't just fall on the developers and researchers. It's on all of us as a society. We need to be having these conversations about AI, talking about the implications, making sure we're guiding this technology in a positive direction.
It's like we're standing at a fork in the road, and we have the power to choose which path we take. This whole deep dive has been such a mind-blowing journey. I feel like we've only just begun to understand what recursive AI is truly capable of.
I know, right? It's been amazing to explore this with you and our listeners. Hopefully, everyone's feeling that same sense of wonder and excitement about the future of AI.
And for our listeners out there, remember that challenge Draper put forth. Go download those datasets, play around with different AI tools, see what you discover. You don't need to be a tech whiz to contribute.
Exactly. It's an invitation to explore. It doesn't matter what your background is. Maybe one of our listeners will make the next big breakthrough. Who knows? There's so much potential here.
Love that. So, to all our deep divers out there, keep that curiosity alive. Keep exploring. You might be surprised by what you find.
And remember, this is just the beginning. The world of AI is constantly evolving. It's going to be an exciting ride.
So buckle up, everyone. The future is looking pretty recursive. And on that note, we'll wrap up this deep dive. This is the deep dive, reminding you to always stay curious and keep exploring.